Hey 8th graders, today's assignment is Introduction to Balancing Chemical Equations. But first and foremost, I want to finish up what we started yesterday. So DLI, this probably doesn't apply to you because you guys had the videos available to you. However, you guys in class, if you remember, you needed to let your experiment that we started in Activity 5 sit overnight for at least 24 hours. So let's just kind of review. You guys mixed iron and fertilizer, and then you added a little bit of water, and then again that had to sit overnight. So if you guys haven't already, you need to go grab your little cup with your reaction in it. You need to bring it back to your desk, and then you guys need to complete slide 16. So this is your observations after 24 hours. Your question right here, could the rust have formed from the fertilizer and the pipes, yes or no? And then your wrap up for this assignment. And then once you guys are done with that, we can go ahead and move on to the next lesson. So at this point, if you guys can go ahead and pause this video now, give a second to go finish up that lab if you haven't already, and then turn in 2.3 and 2.5 when you're all done. All right. So let's move into today's assignment. Today's assignment is the Introduction to Balancing Chemical Equations. Your learning targets for today: I can explain why the law of conservation of matter is important to chemical reactions. So today we're going to introduce this concept of the law of conservation of matter and talk about what that means as far as the chemical equation. Basically, it states that we have to account for every little piece of a chemical reaction. So if we have certain atoms as a reactant, we have to have the same number of those as a product and vice versa. Okay, so let's move on. You guys should have, again, in your bell ringer today, already completed the Activity 1 notebook. You should have added key concept number 8 and number 9 to your key concepts page and added law of conservation of matter to your vocab page. Okay, so law of conservation matter, as I've kind of briefly talked about, is the law that states that matter cannot be created or destroyed. So what goes into a chemical reaction as a reactant must come out of the chemical reaction as a product in some form. We have to have the same amount of it, but it can be arranged differently and therefore would probably have different properties. Okay, and then key concepts 8 and 9, during a chemical reaction, all of the atoms that make up the reactants rearrange to form products. We have to have them all accounted for. Okay, and then number 9, during a chemical reaction, atoms cannot be created or destroyed. If we're not accounting for all those atoms that we put in the reactants, then we're suggesting that maybe those atoms are being destroyed. Or maybe we're looking at our products and seeing things that weren't available as a reactant. So where did those come from? They can't just be created. Okay, you guys should have also completed your warm-up. So what you guys see is this little model here showing we have this reactant of sulfuric acid, and it's forming water. Okay, so Desiree was investigating a chemical reaction. When she heated it up, she found that sulfuric acid changed into water. So sulfuric acid is H2SO4. Here's our 2 H's, our 1 sulfur, and our 4 oxygens. And then our water is our 1 product. It's H2O. Okay, she made the following atomic scale model to show what she thinks happened. All right, so do you think this is a complete model of what happened during the chemical reaction? Think about, if you haven't already, think about what we just learned as far as our key concepts and our vocab for today. Does this follow the law of conservation of matter? So if you guys haven't already finished the notebook and the warm-up, go ahead and take a couple minutes to do that now. You can pause this video, but after that, we're moving on. Okay, so at this point, you guys should all have your laptops facing forward. Those of you guys who are in class, obviously, DLI, you guys can still pause as you go through this and work on each section as I give you the directions for that activity. But again, those of you guys sitting in class, please make sure your laptops are facing forward and pay attention to these instructions so you know. Okay, first and foremost, we're going to watch this video, so you'll right-click, open that link. The video looks something like this. It's a whopping 19 seconds, so please don't get bogged down with how long this video is. Okay, it's the video of a piece of paper burning. It's pretty mesmerizing, but also lacking a lot of content. Okay, all right, moving on to activity 4. I want you guys to really think about that activity as we go into it. So if you haven't already paused, do activity 3, and then let's move on to activity 4. All right, so activity 4, you guys have a little reading. For this, you guys will need to right-click your link to Amplify, and then you guys will open up this article in Amplify. Oh, shoot, of course it's going to do that to me. Okay, so in this article, it's called What Happens When Fuels Burn? You guys need to be looking for these questions here. What happens to the atoms that make up ethanol as it burns? So ethanol is one of our carbon-based fuels. And then what happens to the atoms that make up hydrogen fuel as it burns? So hydrogen fuel is obviously a different type of fuel than what we're used to. So let's go ahead and introduce ourselves to this article. Okay, for the most part, when we think of fuel, we think of things like wood is a fuel, a match is a fuel, or like gasoline is a fuel. Even the natural gas in your house that you burn for maybe heat is a fuel. Those are all carbon-based fuels, and when we burn them, it goes through a reaction called combustion. So it always uses oxygen to burn it, and it always forms carbon dioxide and water. Okay, so you guys can read more about these carbon-based fuels. Okay, and then read about hydrogen fuels. Hydrogen fuels do not go through combustion like carbon fuels do. Okay, so with that being said, I want you guys to pause this video. You can flip your computers back around, read this article, and answer these 2 questions on activity 4, and I'll go ahead and give you some time to do that right now. All right, so you guys should have just finished up your reading, and now we're going to move on to activity 5, which is a simulation. Okay, so we're going to be burning a substance in the sim. So examine the image below. Think about the burning paper video you watched during the last lesson, which obviously was not the last lesson, but was in fact this lesson. Then answer the questions below. Okay, what do you think happens to the atoms of a substance when it burns? There's 3 claims to look at here. All of the atoms are destroyed. Okay, claim 2, all of the atoms rearrange to form a different substance or different substances. Or claim 3, some of the atoms are destroyed and some of the atoms rearranged to form a different substance or different substances. So choose which claim you think is correct there. And let's move on to the directions to the sim. Okay, so you can go ahead and pause and take a second to answer that one question before I give the sim, and then I'll give you guys your instructions. All right, so here are your instructions for the sim. You guys are going to be burning fuel in the sim. Remember that when we burn something, we are causing a chemical reaction to occur by mixing a substance with oxygen at a high temperature. So you guys won't have a partner for this, but you guys are going to use the sim to gather evidence about what happens to the atoms of a substance when it burns. This evidence will help you select one of the 3 claims listed below. So again, these are the 3 claims that you guys just took a whack at to figure out which one was correct. So again, all of the atoms are destroyed, all of the atoms rearranged, or some of the atoms are destroyed and the other ones rearrange. Okay, your directions is you're going to launch your sim. I'm guessing, oh, there we go. I'm guessing I'm going to have to re-log into all of these since I had to do the one. All right, and then laboratory mode A, you're going to press add substance and select hydrogen and oxygen. So this is obviously going to be a hydrogen fuel here. So here's our lab substance A. We're going to find hydrogen. And then our second substance is going to be oxygen. Okay, and then you're going to hit test. So here's your button for test. Watch the atomic scale animation, press results, then review and discuss your final results. And then you guys will go ahead and hit reset and repeat steps 3 and 4 for methane and oxygen. So your next time you guys run this sim, you're going to do methane. So if I were to look at this, reset. Methane is a carbon burning fuel, so here's methane, and then again we need oxygen to burn something, so go ahead and test that one as well. And then you guys can answer these questions here. Did you observe any evidence that atoms are destroyed as a substance burns? So meaning we would have them as a reactant, but as a product they would not be there at all. Okay? Explain your answer using observations from the sim. Your second question, did you observe any evidence that atoms rearrange as a substance burns? So explain your answer using observations for the sim. So all of the atoms are still there, they're just in a different order. Okay, so go ahead, pause this now. You guys can flip your computers back around. Again, you guys are gonna watch hydrogen and oxygen burn together in the first part of the sim, and in the second part, you're gonna do methane gas and oxygen and look for signs of either destruction of atoms or rearrangement of atoms. Okay, go ahead and pause now and complete activity 5. All right, moving on to activity 6. So we're going to be using the sorting claim to test out what the student Jessie has going on. So here's Jessie. She's a student chemist who assists Dr. Young in her lab. While she was working, Jessie added some chlorine gas to a container she thought was empty. After Jessie added the chlorine gas, however, a solid yellow substance formed in the container. Jesse tested the substance and identified it as sulfur. When Dr. Young asked Jesse to explain what had happened in the container, she claimed that a chemical reaction had changed the chlorine to sulfur. Okay, so we got to think about that one. Jesse's claim is that a chemical reaction changed the chlorine to sulfur. So let's go ahead and take a look at an image that represents what was going on with Jesse. So she had this supposed empty container. She squirted in some chlorine gas, and then poof, now she has this solid substance. It's a yellow, stinky substance called sulfur. You guys already probably know what sulfur is if you've ever smelled a match before, if you've ever been to any natural hot springs. That rotten egg smell is sulfur. Okay, and in its elemental form, it's a solid, like a yellow rock. Okay? All right, so do you think that the container was actually empty before Jesse added the chlorine? And then do you think that Jesse's claim is correct? So go ahead, take a second, pause this video right now, and I want you guys to circle your answers for 16, and then answer 17. Explain why you think Jesse's claim is either correct or incorrect. So pause this and answer 16 and 7 when you guys 16 and 17, and when you're done with that, please face your computers back towards the front. All right, let's finish up this sorting tool. So for this one, you guys are going to need the sorting tool link. Right click to open that link. And let's read our directions. With a partner, use the tokens, those are the little circles in our sorting tool, to build the two products Jesse discovered in the container. So we're going to kind of work backwards on this, whereas the other times we've used the reactants, we've built them, and then arranged the reactants to form a product. We're going to work backwards, start with our product, which we know to be sulfur, and then we're going to rearrange them to see if we can build our reactants out of that, to see if we've abided by the law of conservation of matter. Okay? And that'll answer the question as to whether or not that container was actually empty that Jesse added the chlorine gas to. So let's go ahead and take a look at what we're building here. All right, so let's start with our sulfur right here. We're going to add those together in our sorting tool. We can go ahead and reset if you guys haven't done that from the last time. So we built sulfur as one of our products. And as our other product, we had 2 molecules of hydrochloric acid or hydrogen chloride. So we've got hydrogen and chlorine, hydrogen and chlorine. So here's our 2 molecules of hydrogen and chlorine. So those are our 3 products that we got. Technically only 2 products. We have sulfur and hydrogen chloride. Okay, and then what we're going to do is work backwards. We know that we formed 1 molecule, our reactants were 1 molecule of chlorine, so we're going to go ahead and take our chlorine molecules here. Okay, but now we have the question, was there another reactant? Was that bottle empty or not? So you guys can go ahead and kind of look at it, make your decision as to whether you think that bottle was empty or not. Your hint is, what are these things right here left over? Okay, and where should they be? Okay, and then you're going to answer this question, identifying the other reactant. If the container was not empty, which at this point you guys should know that it really isn't, when Jesse added the chlorine gas, then what could have been inside of it? Below is an image showing the reaction inside the container. There is also a table that lists some of the substances that Dr. Young keeps in her lab. The groups of atoms that repeat to form each substance, as well as some of the properties of each substance, are included in the table. So your procedure is use the tokens and the information, which we just did, okay, to determine what the other reactant was. So obviously chlorine gas was one of them. What was the other reactant that came together to form sulfur and hydrochloric acid? Once you have identified the other reactant, answer the questions below. So let's take a look at this table. We had some unknown substance reacting with 1 molecule of chlorine gas to form 1 atom of sulfur and 2 molecules of hydrochloric acid. Okay, so you need to use your deductive reasoning here to figure out what was in that container before Jesse added the chlorine gas. Again, use your sorting tool to help you out there. And finally, answer this question. The other reactant inside the container was, use your draw tool to circle the correct answer or your highlighter to highlight the correct answer, and then explain how you reached that conclusion. Okay, finally, do your wrap up for the day. Do you have any questions, yes or no? If yes, type them below, and then 4, 3, 2, 1, how do you think you did? You guys are all done with this assignment for today. I hope you guys are having a great day, and we'll talk soon. You guys can go ahead, flip your computers back around, finish the rest of this assignment, and hand it in. Have a good day.